Welcome to Asim Code. Help me grow this channel. Hit like, subscribe, and let's continue to learn together. Polymorphism in C++ allows objects of different classes to be treated as objects of a common base class, enabling flexibility and reusability of code. It comes in two types: compile-time polymorphism, also called static polymorphism, which is achieved through function overloading and operator overloading, allowing the same function or operator to work with different types or numbers of arguments; and runtime polymorphism, also called dynamic polymorphism, which is achieved through inheritance and virtual functions, allowing the behavior of functions to be determined at runtime based on the actual object type, even when accessed through base class pointers or references. This allows for more flexible and extensible programs, where different derived classes can provide their own specific implementations of functions. This example demonstrates polymorphism in C++ by defining a base class shape with a virtual function area, which is overridden by two derived classes, rectangle and circle. The program creates instances of rectangle and circle through pointers of type shape asterisk and calls the area function on them. Despite using the same function name, the correct area function is called for each object type at runtime, thanks to polymorphism. The program calculates and displays the area of the rectangle and the circle. This example highlights the flexibility and reusability of polymorphism, allowing different types of objects to be treated uniformly while still executing their own specific behavior. Include standard I/O library. Use the standard namespace to avoid std prefix. Base class shape. Virtual function for area. Virtual allows runtime polymorphism. It enables dynamic binding, meaning the function to be called is determined at runtime. Default area for the base class shape is 0.0, abstract base case. Virtual destructor ensures that derived class destructors are called correctly. Message when shape object is destroyed. Derived class rectangle. Rectangle specific properties, width and height. Constructor to initialize width and height. Override the area function for rectangle. The area function is overridden here, so when area is called on a rectangle object, the derived class version of area is executed. Rectangle's area equals width asterisk height. Destructor specific to rectangle. Message when rectangle object is destroyed. Derived class circle. Circle specific property, radius. Constructor to initialize radius. Override the area function for circle. Like rectangle, circle also provides its own version of the area function. Destructor specific to circle. Message when circle object is destroyed. Main function demonstrating polymorphism in action. Declare pointers of type shape to store addresses of different shape objects. This demonstrates polymorphism as we can store derived class objects in base class pointers. Create a rectangle object and store its address in shape 1. Rectangle with width 10.0 and height 5.0. Create a circle object and store its address in shape 2. Using the same function name, area, for both Shape 1 and Shape 2, thanks to polymorphism. The correct area function is determined at runtime, based on the actual object type. Calls rectangle's area. Calls circle's area. Clean up dynamically allocated memory by deleting the objects. Deletes the rectangle object. Deletes the circle object. Program ends successfully. Now run our code. I really appreciate you all watching. Like, comment, and subscribe for more.